a great pleasure to present one more time StreamingFlow4J for you. And well, I just used to part of the main definition. It's it's the the objective of StreamingFlow4J because it's saying 100% of open source and that enable real-time data processing, Apache Kafka, Redis, and RabbitMQ. No, using a layer of CEP that analyze the streaming data, these pipelines provided by these frameworks, and using the Esper engine and the engine of Esper provides some interface for Java programmers handle all the business logics, and it supports many stream operation, including data filtering, transforming, merging, join, and windowing. Well, even the this is a really hard to understand sometimes in the definition, but in the practice, you're gonna be easy to provide systems using this concept of event sourcing, CQRS, no common query responsibility segregation (DDD). Uh, well, I used to say that StreamingFlow4J is an abstraction of this because there is a lot of patterns and concept and architectural concept and event sourcing and event sourcing uh, uh, um, basis event-driven architecture, and well, this is a lot of concept abstracted here, and this is most easy to see in practice. I will show to you this in practice must here in this presentation, but right now uh, is this no for you understand that there is this concept that a lot of great guys, Martin Fowler, Greg Young, and another great guys of technology just used to talk about. And of course, I used to say that this in resume is a service mesh, event service mesh for event-driven service mesh for microservice and um, all this complexities. Um, it's extracted now. This is some abstraction of this complexity of this concept of architecture, real time, pipelines, streaming processing, and of course, just this is the processing. Um, uh, this is processing asynchronous processing and well, we're gonna see it in practice, and it is most easy to understand. Well, after people see the concept and all and understand the concept, um, the main asking that people made me is what is recommended to, you know. It's so good to make analytics, that data in motion in real time analysis in large amount of, of data from multiple sources, and it allows developers easily create systems and identify unique and fleeting opportunities that companies should act in sometimes window time and so in a given time of frame, and so it's really good to work and it provide all the abstraction of this. How it's real-time processing in in memory. You know, you can use RabbitMQ pipelines or Apache Kafka as well. I forgot I've put here just Redis, but with Redis you can do it everything in memory because Redis is a processing a memory processing non-relational database in memory and provide pipelines and in memory and everything can run an easy way with Redis and uh, this capacity of processing everything in memory and in parallel give the StreamingFlow4J as something very recommended to process massive data or big data. Uh, another 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 thing that I recommend too much is using and IoT mockups, you know, because you can simulate IoT projects and quickly uh, uh, create IoT event streaming, enabling real-time processing and and our uh, our 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 demonstration ahead. I'm using some one mock of this, you know, the IoT mock, how we can provide it in so fast and easy way. You're gonna see, and if you can understand um, the StreamingFlow4J processing when it is applied in StreamingFlow4J, how I say this. Event sourcing and using CQRS and DDD over the architecture of event driven. So when you have uh, some event driven architecture using pipelines and streaming processing or with Kafka or RabbitMQ or Redis, um, it's really recommended to do it because you can just to make real-time data when are you gonna see the event-driven architecture uh, who is from who knows well you will understand that you have producers you have consumers and this is over this processing we have StreamingFlow4J. More than this, it has some API that make all the abstraction of this concept and this architecture, this DDD and CQRS, and even sourcing patterns. And in practice, we're gonna see it. And so, but the API can just receive uh, information or data from producers, create some information and respond. So for consumer that are just waiting this information. And more than this, we have a particular uh, ad, admin producer that provide queries, and this queries this is the the main processing and creating information over the data. And for this, we use queries made in complex event processing. And this is some so important thing that because we are all the time just making it in real time, not just the analysis in real time, but the administration in real time. This is will avoid you to make a redeploy all the time in the application, how traditional applications used to do. Uh, well, for this we have our our REST API, with JSON elements to make all this logic. These logistics are defined here. We have when we just want to add some event, you put this tag. This is so important. You're gonna see this in the real-time example that I showed to you. But right now, we have the definition for add event for rule CP when we want to define some new rule, and rule is indicate the required to be added. Um, the the kiwi is the routing of the kiwi. We using this query, actually using this tag element. You just can define the routing of uh, pipeline will respond for the consumers. Is the destination of the consumers or the analysis of the kiwi, and you can just uh, edit rule CP or delete rule CP in these tags, and of course defining the rule ID that you can just get the ID of the rule and the logs and work with them. Um, this is maybe how I say maybe confused now, but in the example that I will show, do you understand so well that this is so simple and the best way that I know. I know that you can just work in providing event sourcing, secure REST, DDD, microservice, event mesh, and event-driven architecture, and complex event processing, and um, and and QE rules. No, sorry, QE uh, QE routing, because it made this. You're gonna see this in practice. The QE routing that it provide, and all these resources is provided by this abstraction that is complex event processing and in real time, using Esper and and all the frameworks of pipelines like Kafka, like RabbitMQ, and all. Well, this is what our framework does. And well, StreamingFlow4J uh, as this, no, because we use this practical example. Just imagine, do you have some notification contextual of change of a sensor? In this sense here, just you are analyzing um, some temperature sensor, that is the population detecting the temperature, and the subscriber will receive it, and so it can be notified by our application. We're gonna see this practical example, Mr. Heed, and you gonna understand how it easy to do. I'm using here this example. I use RabbitMQ, but I could use Redis as well, and Kafka. Um, so let's go to the hands-on. Huh? The main thing that you should do is go to our main page. Um, this is the URL of our main page, the official page. Well, we're gonna for our main page, just use the in our main page. Um, we go to this is all this explanation that I was making for you here, and there you can just go in the repository in our repository, and we just use here and make it in using RabbitMQ. Uh, you can just make all mm, the clone of the project here. I'm gonna do it now, right now. Um, as of now, it made the all the clone of the uh, the repositories in um, our official GitHub page. Well, I will stop here, and in the next video that I will record for you, I will show for you the practical example. But as of now, as this, I thank you too much. And the next video is the continuation of this point. As of now, I will just provide the information about how you can do it in practice. And well, that's it.